Today we're going to talk, my name is Ann Holmberg and welcome to this webinar where we are going to talk about efficient testing, learn how to use the Biomarker Workbench. The Biomarker Workbench is a fairly new feature in the Qlucore software, and it's optimized for getting a very quick overview of your dataset and also so that you are able to focus on the most interesting signals in your continued analysis. It includes easy setup of a suite of different statistical tests to run on all annotations in a batch mode. And the objective is to identify effective drug candidates, treatments, or other relevant signals. And the results are presented in tables, and the structured outcome can be directly used for your following analysis steps. And then we also have something called response variables who will assist you in finding correlation between annotations, which is normally quite hard to find with other tools. So we'll show you how you can do that. And in the Biomarker Workbench, we introduce some new terminology. So we talk about explanatory variables, which is the combination of statistical test and sample annotation. Yeah, in the same way as we have always used it, but now it has a name. And then we also have response variables, and traditional variables like genes, proteins, and so on are response variables. But now sample annotations can also be response variables when we are looking for the correlation. Okay, so let me show you how this is done. So I now share the software with you. So let me just check that there are no comments. No. Yeah, I will share the slides with you after this webinar. Okay, so now I will load a data set of gene expression data that's already prepared as saved as a GE data file. So that will load directly. So here we are now with 24 samples and 50 variables, genes. And we are looking at our 24 samples in a PCA plot here. And we have a lot of different annotations, but let's pick one of them and color by, in this case, treatment. So this patient has received, these patients have received 3 treatments, placebo, drug 1, and drug 2, like that. Okay, but I'm also very interested in all the other annotations, but it's quite a big job to go through all of them and establish if they are strong signals or not. So an efficient way of doing this is to use the Biomarker Workbench. So by using this icon here, I open up the Biomarker Workbench. And here I can add all my variables in one, all my sample annotations in one go by just pressing the Add All icon here. And then you see that all the sample annotations are here, at least the ones where there are some groups. If it's just unique IDs, it won't be added. And then we also add a suitable test for the type of data, and you have the possibility to change to another test. So here we have a lot of the tests available, not all of them, not the non-parametric test, for instance, but most of the other ones, like that. And then I can run all of these tests in one go by just pressing run, like that. And then we have the overview here, where we see how many variables or genes do I find that has a Q value below 0.05. And here you see that the strongest signal here, okay, for some some reason I pressed this icon twice, so I get the results twice here. But we see that patient ID is a very strong signal. Okay, so there are big differences between the patients, but I'm not really interested in that because they are probably, yeah, that's not my main interest here. But I'm interested in, for instance, um, how many treatment and time point where I have quite a number of variables, genes that have a good Q value. So that's interesting. And I have the detailed results here. So let's just do this again so that I just get one like that. So run. So okay, now I only have everything once. In the detailed view here, I have all the Q values for each of the tests. So here we have the treatment, the Q value, and also the P value, but I will actually take away some columns. I take away the P value column, and I also add the symbol column, take away the P value there as well. I get a smaller table. So here we have now the Q value for the ANOVA or multigroup comparison on treatment. And then you see here that we have 10 plus variables with a Q value less than 0.1. Okay, interesting. I do the same for the time point, and I see that I have a couple of genes with a good Q value. What about smoker? Yeah, not fantastic. One variable, sex, some more, and so on. So you can go through all your annotations very quickly to identify where you have the strongest signals. If we add, if we know, for instance, that we have covariates, maybe sex is a covariate, so let's just add that as an eliminated factor. So then we take away the effect of sex, and then we run again. And then we see here that, okay, that actually increased the number of significant variables we found for treatment. So sex had some effect here. Okay, and if we look at the details again, treatment, for instance, here we have it. So now maybe I would like to create a list of the most interesting variables here. So I make a list of all the genes that have a Q value less than 0.05, and I save that list by just pressing here, and I give it a name. So ANOVA on treatment, like that. And then I go back to my main window and see that, okay, here is the list that I just created. And if I want to check the effect of these genes on my samples, I just make this the input list by ticking here. And then we see that, yes, these 7 genes are actually good at separating the treatment groups. And then you can continue to work with this list if you want to. But now I want to continue my analysis. So I take away this tick here so that I activate all the genes again. And then I return to the Biomarker Workbench. So now I take away all of this by just pressing the dustbin. I also take away the eliminated factor like that. And now I will add only one annotation. So with the plus sign, you add the annotations one by one. So I'm very interested in treatment. So let's continue with that. And I'm interested in, let's add also time point and maybe also sex, like that. So if I now press controlled experiment here, the meaning of that is that each annotation is tested and the other two are, the effect of the other two are eliminated. So these would become eliminated factors. And so for treatment, time point and sex will be eliminated factors. For time point, treatment, and sex will be eliminated factors, and so on. So when I press run now, we look at the overview, then we see that for treatment, time point, and sex are eliminated factors, and so on. And these are my results, like that. So I have them here. Okay, so you see that you get this very easy to understand table with all your results at all points. Okay, what more can I do? Let's take away sex and time point and focus only on treatment. If I go down here, you see that I can also add post hoc testing. So if I would like to have a look at Tukey's range test and also fold change for the pairwise comparison of the groups, I can do that by just ticking these boxes. And when I press run, we get all of these results. So here you see that I have the fold change for the pairwise comparison of drug 1 and drug 2, like that. And for the pairwise comparison of placebo on drug 2 and placebo on drug 1. Then I have the difference, which is the same as the log fold change here for the same pairwise comparisons. And then I have the Tukey p-values, which will tell you how good these groups are to separate from each other. So you see that for this specific gene, placebo and drug 1 separates very well as drug 1 and drug 2, but placebo and drug 2 doesn't really separate, and so on. So you get a lot of information here, and then you can easily export the full table as a TSV file, and then continue to read that into Excel and continue to work with this and filter and so on. You can also do a full export, which means that then you get an export including all the columns here, like that, all the available columns. So a very quick way of generating a lot of results that you can then filter on to decide what you want to continue with. Okay, and now we want to, so we now focused on the explanatory variables and had a look at a lot of different possibilities there. Now we will have a look at the response variables. We've already had a look at them because all the genes are actually response variables, but now we will focus on how we can work with the sample annotations and look for correlation between sample annotations. So now sample annotations are also treated as response variables. So how does that work? Okay, so let's say that we keep the treatment, but we take away the post hoc information here, post hoc analysis information, like that. And now I would like to compare all my sample annotations with treatment. I take away treatment because that correlates very well with itself. But I'm not interested in all the genes, so I can say that I'm only interested in comparing sample annotations. So I take away the response variables from the data set. So in this case, the variables. I just focus on the sample annotations. So now when I run this, the Q value here will help me to understand if there is a correlation or not. And you can see that we have a very strong correlation with patient ID. But again, that's probably because the patients have been assigned in treatment order. So all the placebo samples have number 1 to 8 and so on. So I'm not interested about that, but I can see that there is quite a strong correlation with smoker, meaning that maybe there is an overrepresentation of smoker in one of the treatment groups, for instance. And there is also a fairly strong correlation with diabetes. So again, there could be an overrepresentation of diabetes patients in one or several of the groups, and yeah, rather weak, but still correlation with blood pressure. So this gives me information on that there could be other signals in the data set that affect my result when I now, what I'm looking for is um, which genes that are good at separating the different treatments from each other. But it could be that smoking and diabetes and maybe blood pressure also has an impact. So this is very valuable information. So you can now go back to your data set and try to establish, okay, how big is this signal, and can I do anything to compensate for that? Okay, so that was really what I wanted to show you today. So you now see that the Biomarker Workbench is a really good place to start with a new data set. You can get a very quick overview. You can get a feeling for if there are other factors that influence your results and so on. And then you can focus your interest on the annotations where you have the strongest signal. So extremely useful. So let's switch. So any questions? I now open the chat to see if there are any questions. And while you are thinking, let me just talk about upcoming webinars here. So next week we will talk about our many 2D plots and statistical testing, and also how you can analyze O-link proteomics data. And then later on we will have a basic hands-on training again. And you register for these webinars in the same place as you registered for this one. And if you have any questions, you are very welcome to send me an email or support. So let me just check again that there are no questions. No. I will send you the slides after this webinar. So by that, I would like to thank you very much for your attention today. Bye-bye. Have a good rest of the day.